Okay, so today we have another optimization problem, and it says determine the maximum possible vertical distance between the line y is equal to x plus 2 and the parabola y is equal to x squared for, and then we have our restriction where x is in between -1 and 2. So before I get into the solution, let's move on to the diagram that I have here, and I just want to explain a few things before we carry on. So firstly, our straight line y is equal to x plus 2, that's clearly highlighted in green, and then our parabola x squared is highlighted in blue. Okay, so we have our restriction, which is -1 and 2, and you might ask me, well, how do I know that these 2 points are the intersection points? Well, if you say I want to know where this one is equal to this one, then you would solve for that. So you'd say, okay, x squared minus x minus 2 is equal to 0. Then factoring this would be x minus 2, x plus 1. Let's double check that. So that gives me -2. Okay, that's correct. So here x would be 2 or x would be -1. So here you can see that our restriction is actually just the points of intersection of these two functions. So we want to know the maximum possible vertical distance between these two functions. Now, how do we do that? Well, let's start off with what we know. Well, we know at these two intersection points, the distance is going to be 0. Okay, so let me just state that. So let's say at x equals -1, 2, let's say d is distance, the distance is going to be 0. Okay, so I'm just stating this just for you guys to understand, because I'm gonna prove this. Okay, so how do I get the vertical distance of two functions? Well, if you remember from a trick, well, I can say the top function minus the bottom function is going to give me the vertical distance at any point. Okay, so let's look at this graph. Well, if I look in between the restriction, which is -1 and 2, well, I can see that my straight line is going to be above the parabola throughout. So I can say, well, my top function, let's call this function d of x. This is my new function. This is going to be my vertical distance. And I said, well, my top function minus my bottom function is going to give me the distance at any x value. Okay, so let me prove this. I said I was going to prove this. So let's take 2. Okay, so we know the distance at x equals 2 is going to be 0. So let's put 2 in here. So 2 plus 2 minus 2 squared, that's going to be 4. This is also going to be 4. And what do you know? The distance at x equals 2 is going to be 0. Okay, so we know this is true. We know this gives us the distance at any x value. So how do I get the maximum from this? Well, this is just an ordinary function. So if I take the derivative of this, well, that's going to be 1 plus, that's going to be 0, and taking the derivative of that, that's going to be -2x. Okay, now if I set d prime equals 0, this is going to give me the maximum. Okay, this is going to give me the x value at which the maximum occurs. Okay, So let's set it equal to 0. So let's say 0 is equal to, and this is just minus 2x plus 1. So taking that on the other side, let's take 2x on the other side. So this can be 2x equals to 1, and x is equal to a half. So coincidentally, my broken line was, well, it looks like it's at x equals a half. So we know at this point, this is where the maximum vertical distance occurs. So now what do we do with this x value? We know where it occurs, but we still don't know what the maximum possible vertical distance is. So we know that we have a function that gives us the vertical distance at any x value. So let's just plug that in. Let's say, well, d of a half, and that's going to be equal to a half, plus 2. It's going to be minus, and then a half all squared. So how can I rewrite this 2? Well, I can say it's the same thing as 4 over 2, because that just equals to 2. So if I write this as that, I can add these two together. This is going to give me 5 over 2. Half plus that is 5 over 2. Minus. Now this is going to be 1 over, that's going to be 4. 2 squared is 4. Now let's rewrite this 5 over 2. How can I rewrite that? Well, if I multiply the top and the bottom by 2, I can say that that's the same thing as 10 over 4 minus 1 over 4. Combining these, I can get, well, the maximum possible vertical distance in this restriction of minus 1 and 2 between these two functions is going to be 9 over 4. And that's our final answer.